Hello, welcome to today's lesson in CH110. So CH110, I don't know, with other institutions like UNZA, Mulungushi, I don't know the codes, but for CBU that is CH110, that is chemistry, introductory chemistry. So, like I promised you, the document that I sent in the first place, I told you to say, the first document shall cater for, number 1, introduction to chemistry. Then number 2, we shall do stoichiometry. Okay, these two. So for this one, it's just a great tool of work that we just need to revise. I just need to revise with you. Even this one, stoichiometry. It's just the matter of new concepts that have just come in, but almost one and the same. All right, so let's proceed. Let's not waste much of the time here. So we'll start with introduction to chemistry. Intro to chemistry. So at the end of the day, what do you need to know? The first thing, scientific method. Then classification of matter, properties of matter, units of measurement, uncertainty in measurement, dimension analysis, Dalton's atomic theory, modern view of the atomic structure, periodic table, molecules and molecular compounds, ions and ionic compounds, then naming of the simple compounds. Then you are covered. Whether these can look lengthy, but they're just simple things that you have just to know. All right, so just pick the main points. Okay, just pick the main points. So we'll start with the scientific method. Some of these questions you guys are just asked to say, can you state? Okay, can you state? So under scientific method, if they tell you to say define a scientific method, this is just the word in which scientists use to solve problems. Just that simple definition, you get 2 marks. All right, so another thing that they ask about scientific method is to state the procedures that are involved or that fall under scientific method. Okay, so now here are the steps. Number 1, scientists do make the observation. Okay, first they observe. So the first thing is observation. When they observe, the observations can be based on either quantity or quality. You know what quantity like, and also quality. Quality can be color and the likes, then quantity, mass and the likes, you get. Then number 2, after it has been observed, the scientist must formulate an hypothesis. It's just a matter of stating hypothesis. Hypothesis is just a possible explanation for the observation. Yeah, that's all. Number 3, they need to do now the experiment. Okay, the experiment. When they perform the experiment, then they'll come up with a theory. This theory further can be expanded into a law. All of these, they fall under scientific method. Simple things. So you just need to know, in case you're asked to say, can you state some of the procedures that fall under scientific method? We've got observation, hypothesis, experiment, theory, then law. All right. They can even tell you differentiate between a law and theory. So you must be able to do that. I've sent in that document. It's just about studying. Let's not waste time. All right. So from there, let's look at the classification of matter. Grade 12 work. We defined what matter is as anything that occupies space and has got mass. Then from there, we said all materials in the world are composed of few or more hundreds of of elements. Then you guys defined what an element is, to say an element is the smallest substance that cannot be further broken down, or rather, chemically into simpler and stable substances, all those things. So now, here is the thing. what you have to know is that these elements are the ones that do form different compounds. Okay? So since we've said an element cannot be further broken into a simpler substance chemically, so it can be added, okay, or rather combined to form something. So now, the thing is, elements combine in only two fundamental ways. What are these two ways? Number one, elements can combine in a physical change. Okay? Elements combine in a physical change. When they combine in a physical change, they form what is called a mixture. Then, secondly, elements can combine in a chemical change. What is formed? It's the compound. Simple stuffs. So, compound, mixture. So you can even define to say a mixture is the combination of two or more elements that are physically combined. Then this one is just say chemically combined. Those are the only two things. Then you guys know to say, physical change, chemical change, all those stuffs. We want to do. My main area of interest is to talk about stoichiometry. Stoichiometry, I mean. Okay? Stoichiometry, not even introduction to chemistry. It's just a matter of studying, okay? It's just a matter of studying, then you understand. Then let's talk of units of measurement. We are done with this. Units of measurement. Units of measurement. Here, the main focus, mainly what they look up is just the conversion factors, okay? You'll be told convert from, say, grams, like milligram to grams, all those things. You know these guys. Let's not waste time. Then from there, let me just talk about under units of measurement. Let's talk about temperature. We know the definition of temperature to say this is just a measure of hotness or the degree of, whereby others can define to say how hot or cold a substance is or a place is. Yeah. So now, under temperature, the most important thing is to know the units, okay? The units in which temperatures are labeled. So we've got Kelvin as the SI unit, then we've got degree, then lastly we've got the Fahrenheit. So you as a student, first year, you have to know how to convert from degree to Kelvin and vice versa, then also degree to Fahrenheit, all those things. Because you guys, a question can be asked in Kelvin, then it's demanding you as you work out to work out using degree units or vice versa. So you have to know the trick. So here's the thing. If we are converting from degree to Kelvin, it's just the simple stuff. Just add 273.15 to that thing that has been given. For example, if I have 30 degrees, okay, I will just say 30 plus this. That's all. Then, if I'm converting from, if I'm converting from Kelvin to this, okay, what should I do? So I'll say degrees Celsius, okay? I'll say the temperature in Fahrenheit minus 32, then multiplied by 5/9 degrees. This is, you must master this. You must know this, okay? So temperature in Fahrenheit minus 32 times 5/9. So the temperature that has been given, you put it here, you subtract 32, then multiply by this. Then, if I want to convert from degree to Fahrenheit, so I'll just say Fahrenheit is equal to the temperature that has been given in degree, okay, times 9/5 plus 32. So the difference here is this 9 is on top, here it's down. Then here we are subtracting 32, here we are adding 32. You must also know this. I think I sent this in the document. So let's not waste time. And there are questions and answers that are in that document. Okay. So let's proceed. Then from there, where is that thing? We can look at the periodic table and the likes, then also naming of the compounds. I think this is where my interest is. Periodic table is even this guy here. We know it from our grade 12. You know to say this is a group 1, group 2, then transition metals and the likes. Then you must also know the names, okay? We've got the alkali metals. Group 1 metals are also called alkali metals. Group 2 elements are also called alkaline earth metals. Then these are called what? Transitional metals. Then we've got group 6 metals that are called the chalcogenes. Then we've got group 7 elements that are called halogens. Then we've got group 8 elements that are called what? Noble gases. Very important. When you know these, perfect then. Right. This is Fiamu grade 12 with let's not waste time. Naming of the compounds. That's where my interest starts from. And pay attention. So, let's go. Naming of the compounds. Naming of the compounds. So you guys must get acclimatized to this topic, okay? Because naming of the compounds will help you to handle stoichiometry and also gases, then organic chemistry, thermochemistry. These topics, those topics that I'm mentioning are the topics that are ahead of you. So you must know this. This is the foundation, okay? Because if you cannot formulate the name, you cannot come up with the compound's name. How are you going to construct the equation? You cannot even balance it. So chemistry, apo baya mantwatio na ya kumpika na chitashan na mbokushtia kukungo nyapa. All right. So naming of the compounds. Now, when naming of the compounds, I will go a little bit in detail so that you can understand. I will divide into different parts. So I'll start with the binary. I'll start with binary ionic compounds. Number 1. Then number 2, I will have binary covalent compounds. Okay. Then I will have binary. What was I saying? Hope I wasn't saying binary. Chisung, which is binary. All right. So binary ionic compound, then binary covalent compound. So first, let me focus on these two. So now, when we say binary ionic compound, we know what ionic compounds are, and we know what covalent compounds are. All right. So ionic compounds, when we're talking of ionic, we are talking about a metal bonded to a non-metal. Okay. Then covalent, we are talking about non-metal bonded to non-metal. So let's go in with examples. I want to be dealing with examples. For example, if I have KCl, all right, then I've got also MgBr2, then we've got CrO. Then they tell me to say, can you name this? All right. So we know to say when you go on your periodic table, K is here. Where is K? K is here in group 1. And this is potassium. Then Cl is here. This is chlorine. All right. So I'll be able to say, okay, this is the metal with the non-metal. So now, this is the potassium and this is chlorine. So I will have potassium chloride. This one will change from chlorine to chloride. So you must know those properties to say if this one reacts with this. Group 7, for example, fluorine changes to fluoride, chlorine chloride, bromine bromide, iodine iodide. Okay, all those things. So you have to know all those things, right? So here it's potassium chloride. Then this is magnesium bromide. Then this is calcium oxide. All those things. So here is the first part, which is kind of simple. Then let's go to binary ionic compounds type 2. Binary ionic compound, which is type 2. So now, in here, metals in these compounds form more than one type of positive ions. Okay? Then apart from that, you're going to discover that charges on the metal ion must be specified. All right? Then we've got also other situations whereby maybe, what can I say? Maybe Roman numeral indicates the charge of the metal cation. You get all those things. So let me not explain. Let me give you an example. For example, if we have copper and also bromide, okay? How can you write this? So this one can be written as copper 1, bromide. Hope I'm right. Yes. Yeah, right. Then if I have FES, how can I write this? I can name it to be, I'm going first to assess this. All right? To say, okay, sulfur. Sulfur is in group what? I will check here on the periodic table. It's in group 6. Then this one, it's falling somewhere. Where? I can see it. All right. So this one, I'll say, okay, this is iron, and this is what? This is sulfur. So it has to be written as iron 2 sulfate. Another example, the last one, PbO2. How can I name this one? It will be lead. Lead for oxide. Why? This is because there's 2 here. Okay? The valence of oxygen is 2. So for me to have another 2 here, meaning in the first place, let me emphasize on this one. Let me even rub here so that it makes sense to you. PbO2, okay? For me to write it as lead for oxide, where is it coming from? So Pb had 4 as plus, then oxygen had 2, all right, as negative. All right, so in this case, I'll reduce. Here it's 1, here it's 2. I'll remain with 2. So it will be Pb2O. So when I cross multiply, this will go this. Then here I've got 1. There's so it will be Pb, or these 2 will go here. This is how they write. Hope it has been understood. Let's proceed. Let's proceed. Let's proceed. If you were me, the key, the heart of chemistry. All right. So now, we've got also polyatomic ions under naming of the compounds. Polyatomic ions. I think I just need to come up with a table to help you guys, because you need to master this. Because we've got things like OH, okay? We've got things like NO3, NO2, CO3, we've got PO4, we've got, all those things. You know what I'm talking about. This is hydroxide, this is nitrate, this is nitrite, this is carbonate, this is phosphate. Okay, we've got SO4 with sulfate and the likes. Negative, 2 negative. Then PO4 should be 3. Yeah, then this is 2. Okay, so these, you need to know these radicals. We call these as radicals. All right. So now these radicals may even react with metals and the likes. So for example, if a calcium reacts with the radical of this, so we'll have calcium carrying the valence of 2, then carbonate carrying negative 2 as its valence. So these will cancel. So I will have calcium carbonate. Let's also pick phosphate. Let's assume phosphate reacts with the calcium phosphate. If I want to write the chemical formula for calcium sulfate, phosphate, calcium phosphate, how would they be named? So calcium phosphate. So calcium is in group 2, hence it has got the valence of 2. Then phosphate, PO4, it has got the valence of negative 3. So when I cross multiply here, these 3 will come here, then these 2 come here. So it will be 3. To be clean, I'll put this in brackets, PO4. then this will come to C is the formula for calcium. So some lecturers, I mean, they will tell you like calcium phosphate reacts with to proceed. Can you write the chemical formula? So this is the reason why I'm trying to give an emphasis on you need to know how to drive this. You need to know how to write this. All right. Because if you do not know, you cannot balance, you cannot solve these other questions that may be given. Yeah, so I think I've now talked about naming of the compounds and also writing some kind of chemical formulas. So this is, I think this is all about the introduction to chemistry. We are done. I think let's go now to the main point. Stoichiometry. 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 It's stoichiometry. Tapaba chemistry. All right, and more concept. You can say Vanya concept. You guys, I think I can't wait to meet you like in person, not this online. You know. All right. So what do you not know? The outcomes. What do you have to know? So at the end of it, you have to, one, know how to find the atomic masses, which is, I mean, the atomic mass unit and also the average mass unit. I mean, mass of an element. Then apart from that, what else? You have to find, or rather know how to find the percentage composition of a compound. All right? Then apart from that, you have to be able to determine the empirical and molecular formula. Okay, then 4, you have to know how to balance the chemical equation. Then also finding limiting reactant. All right, then apart from that, also the amounts of reactants and the products. Then lastly, combustion analysis. All right, so you are covered. You are covered. Your job is just to smile. So we are under stoichiometry. So I'll be referring to the examples that I sent. Where is that paper? I'll be just picking the main points. I'll just soap. All right, so okay, let's look at this question. So this question is saying, when a sample of natural copper is vaporized and injected into a mass spectrometer, only 2 isotopes, namely copper 63 and copper 65 are seen. Use the atomic mass and percentage as isotopic abundance stat of those isotopes shown in the table below to calculate the average mass of natural copper. All right. So this question actually is talking about finding the atomic masses. Simple stuffs. So this table that has been given here. All right. We've got an isotope, atomic mass, and also isotopic abundance. So this is just like a formula whereby the average mass is given by the isotopic abundance divided by 100, since it's in percentages, then multiplied by atomic mass unit. Then you're done. You also add to this another one. So we've got this and this. It's more or less like you're finding the average. So you just need to divide this by 100, then multiply by this, then plus this divided by 100, then multiply by this. Then that's what, there's nothing. So let's proceed. What a thing. Okay, the mole and molar mass of element. Okay. How to find the moles. Moles and molar mass. Molar mass. So mole and molar mass. So look at this question. It is saying a silicon chip used in integrated circuit of Thelma's laptop has a mass of, so silicon has the mass of 2.84 mg, which is milligram. All right. Determine both the number of moles and the number of atoms in the chip. All right. So here they are looking for you to find the number of atoms and then the number of moles. In fact, the first one is the number of moles. Then number 2, number of atoms. Simple stuffs. These things, solutions. How do I go about this one? We know the general formula to say number of moles is equal to mass over molar mass. Okay? So now, this mass is the one that has been given. Make sure the first thing, observe the units of the mass. Mass must always be in grams, not in kg. Okay? Unless in physics. Physics, that's why we deal with kg. But in chemistry, we deal with grams. So make sure if it has been given in grams, in like this one, it has been given in milligram, convert it to grams. Otherwise, and you're going to discover that maybe this question is carrying 10 marks, whereby it has got tomatrolling questions whereby Bishan, so if you've made the mistake, if you just make the mistake at the first question, then you are gone, my guy. You are gone, my mama, my data board. All right. So from there, we use this formula, number of moles equal to mass over molar mass. The molar mass is the one that you get from that compound or element that has been given. So in this case, they've told you to say it's what? Silicon chip. Okay. So number of moles equal to mass over molar mass. The mass, when you look at the periodic table, it's the mass that has been given here is 2.84 milligram. So when you convert this, you just divide by 100. So 2.84 divided by 100. When you punch on your calculator, it will give you something like 2.84 times 10 to the power -3. Divide by the molar mass. The molar mass of the same compound or the element that has been given, you check on if it's an element, you check on the periodic table. If it's a compound, find the molar mass like I would do. We'll find together. So when you divide, here you just put mass. Okay? Here you just put mass, then here you put molar mass. Then that's all. The calculations that were done here. That's all. Simple stuffs. All right. Then, how to find, the question is number of moles, then again number of atoms. So now, the relationship between the number of moles, the number of atoms, and also Avogadro's constant number is that the number, then the also mass to say, mass can also be given by number of moles is equal to the number of atoms divided by Avogadro's constant number. This relationship. So number of moles is equal to number of atoms over Avogadro's constant number, which is the fixed number 6.022 times 10 to the power 26. If my memory serves me right. 20 to the power 10 times 6.022 times 10 to the power 23. My memory serves me right. Yeah, I think I'm right. It's the Avogadro's constant number. That's the one that you use here. Then here n, you put the what? You put the number of atoms. So if you're asked to find this, you just make this as a substitute formula. It comes here, then the number of moles that you found here, you put here, you multiply. Then you're home and dry. Let's go. We need to touch other things until we reach the what's this? The combustion analysis. Okay. So let's talk about how to find molar mass and percentage composition of a compound. So molar mass. These are simple things. Molar mass. I'll just demonstrate. For example, if they tell you to find the molar mass of calcium carbonate. Okay? So calcium carbonate, this is the compound that is made up of calcium, carbon, and oxygen. So, how to find this? Just be humble. Dunga kabwa chakakeni, just do it. Okay? When you do like this, then you see how many atoms of oxygen am I having? 3. So I'll say 3 times. You go on the periodic table. Oxygen is in group 6. Then the mass number is 16. So you say 3 by 16, which is, then here carbon is 1. So 1 times 1. So, carbon is 12. So 1 times 12.01 is equal to, then Calcium. Calcium is in group what? Calcium is in group 2. It has got 40.08. So it's 1 times 40.08 is equal to. So when you multiply, when you get your calculator, it is giving me 16.3. So I will have 48 plus 12.0. What was for carbon? All right, carbon was 12.01. Then plus 40.08. When I add these, they should give me approximately 100 if my memory serves me right. Okay, so I'll have 48 plus 12.01 plus 40.08. So it's giving me 100.09 grams per mole. You put these units. Okay. Hope they're being seen on the camera. All right. So this is how you find the molar mass. It's very important by the time we'll be dealing with empirical formula and also molecular formula and also combustion analysis. I think this step. So just be humble. You just do this. You count how many atoms am I having for each element. So if we've got 3 shanshan of oxygen. So you say 3 times molar mass. I mean the mass number, then carbon, all those things and the likes. All right. This is how we find the molar mass. So we proceed. What other things do we need to talk about under stoichiometry? Okay. So you can't feel these guys, simple things, guys. Let's now talk about determining the formulas, which is the empirical and the molecular formula. This is very interesting. And this question is rarely left, guys. So you have to know it. So determining the formula of a compound. All right. So the formula they're talking about empirical and the molecular formula. All right. So we'll start with empirical. Sharp. You guys need to sleep. Empirical formula. So what example do I have here which I will use? You can even start with the definition. Empirical formula is the simplest whole number ratio of atoms in a compound, or a molecular formula is the exact formula of a molecule given the type of atoms and also the number of each type. So now these are the definition. You need to know the definition of this and also this, the one which I sent in the document. Then also the relationship. Yeah, the relationship will be looked at the end. All right, so let's start with the empirical formula. Or if you're just too busy, I can still give you the relationship which is there. So the relationship is that molecular formula is equal to the number times empirical mass. So this number must be found, and I will tell you how to find this, and I'll show you. Then this one first is the one that we have to work on. Then we proceed to this. All right. So let's go. There's no time. Empirical formula. Okay. So empirical formula, if you've been given the situation, for example, here is the question. It's saying, I'll bring it on the screen. Hope you guys can see it. It's saying the most common form of nylon is 63.68% of carbon, 12.38% of nitrogen, then 9.80% of hydrogen, and 14.4% of oxygen. Calculate the empirical formula for this nylon. 2 marks. All right. So you need to collect the elements that are there. You write them down. So here they've told us about carbon, then nitrogen, then hydrogen, and also oxygen. Okay? Then from there, you put the percentages. Sometimes they can give you in percentages, then at times they can give you in masses. All right. So here, carbon, we've been given it's 63.68. Then nitrogen, we've got 12.38. Then hydrogen, okay, let me just do this. Then hydrogen has been given as 9.80. Then oxygen has been given as 14.14. So due to the small space, I will just use the answer booklet, but I will just explain in detail. So look at this. So there are only simple ways that must be followed in order for you to answer. Okay, so you write the percentages that have been given, like the way it has been written on this table. Okay, so we've got carbon, nitrogen, hydrogen, and oxygen. These are the percentages that have been given here. Okay, then from there you assume to say the percentages, when I add this, and that, I will have 100%. Okay, so meaning I need now to divide the percentages or the masses that have been given by, okay, by the moles, I mean by the mass of that particular element, in order for me to come up with a mole. Because remember, we're talking about stoichiometry and mole concept. Okay, so in this case, the mass that has been given is 63.68. When I go on the periodic table, I find that carbon is 12, then nitrogen is 14.01, hydrogen is 1.008, then oxygen 16. So I'll need to divide this, divide by what I'll get from the periodic table as the mass number. Then I put. Then from there, when I divide, I'm obtaining these small answers when I punch on my calculator. So 5.31, 0.884, then 9.72, 0.88. Then from there, pick the answer which will be a smallest one among the given ones. So in this case, the smallest is this, 0.884. So now when you pick that, you divide it throughout. So in this case, I'll divide this, divide by this, divide by that. When I divide throughout, I'll obtain this, 6, 1, 11, 1. So in short, I will just write down the letters of the elements that were present. C, then I write the number which is corresponding to this, the one that I obtained in the first place. So 6 is falling under carbon. Then nitrogen has got 1, meaning I cannot just indicate 1 for the sake of cleanness. Then hydrogen has got 11, so I'll put here, then oxygen has got 1. Yeah, so this is the empirical formula. All right, now let me give you the tricks about this. Sometimes there are times whereby when you divide, then you obtain the decimal answers and the likes. So here is the trick. If at all you are carrying out, or rather you are trying to find the empirical formula, then you end up having points and the likes. You can only round off if you have x is equal to, for example, 0.89. You can round off this. Okay? You can round off. Then, also number 2, if you've got x is equal to 0. All right? 0. Which x is less than, all right, is less than 0. Let's say 24. You have to round off this. What I'm talking about is if I have 4.13, I can still round off this, then I obtain 4 just as the answer. Then here also, I can round off here, then I obtain 1 as the answer. But if I obtain something like 8.3 to 8.7, you get these two numbers that are coming in between of 0.2 and 0.8. You're not supposed to round off this. What do? You need to look for a whole number which you're going to multiply with this. When you multiply, they will give you the whole number, or rather they will take you to this such that you can round off. I think I've made myself clear here. I'm saying if at all you're having the answers that are giving 8.3 or 8.4 or 8.58 up to this, you're not supposed to round off like this. You obtain 9. No. What do? You look for a number. For example, you can try out 2. Multiply 2, it will be 16. It will be 16.6. All right. Still, it's not falling. It's not falling in the range of 0.89, such that you can round off. Then you can try 3, just like that. Here, when you try 3, it will give something. Then from there you can round off. Yeah, that's it. So that's how you go about the empirical formula. Now, after finding the empirical formula, you're going to discover that maybe the next question will be find the molecular formula given that the molar mass, they'll give you, for example, if they tell you to say determine the molecular formula the compound contains and the likes, and as the molar mass, and the molar mass is 580 grams per mole. All right, so now, just like I told you to say, molecular formula is given by N, open the brackets, meaning multiplied by empirical formula. So how do you find this? So this N will be found by the molar mass that we've been given. The molar mass given divide by the empirical formula, or rather the empirical mass. What do I mean? The one that we had, okay, sorry, I think the light has gone off, but we'll proceed. Let's go. All right, so the answer that we had obtained, for example, in the first place, upper, we said it's Cn. Here you say empirical formula mass. This is how we find N. So now what I'm talking about is here, this one we've been given, it's in the question. Then now here, how do I get this one? So the empirical formula that you had found in the answer, this one, C6NH11 and the likes, okay, is the one that you found to say C6, then NH11O. So you need to find now the molar mass of this. From that kind of thing that I told you to say, you do like this. 1.0 times 11 and the like. So when you find this, then you put it here. So what you get here, you divide into what has been given here, then you find N. Mostly it would be 2 or 3 or all those things, or 1. They arrange in this. Then you multiply this by the empirical formula that you found. What you get is the molecular formula. As simple as that. All right, so that's it. I think in a nutshell, But you know, I will do this video like I will teach this in physical when we'll be having physical lessons, because you know I'm kind of tired, and you can just get a voice to say not that much. But I know you're getting something. I know you're getting something. So let's talk about combustion analysis as the last part. Then imokulangala fekunganda, at least you need to watch this. You have an idea. Physical lessons will be hot. I'm telling you, it will be hot. So combustion analysis. You know, they don't tell you to say this is the combustion analysis. No. But based on the analysis that you yourself carry to say, okay, how this question, the way this question has been phrased, this is actually the combustion analysis question. So how are you going to know? In fact, I've skipped limiting reagent, which is not the case. Okay, let's do this. I'll make another video talking about limiting reagent and combustion analysis, because the lighting system has gone poor. So see you soon.